Hello everybody. Today we're going to be talking about vector quantities and vector addition. You might recall back in lesson 2 we learned that some quantities are vectors and some are scalars. Vector quantities are those which have both a magnitude, which is a size, as well as a direction associated with them, whereas scalars are quantities that have only a magnitude. They have only a size. So when dealing with vector quantities, you have to have some sort of mathematical technique to not only deal with the sizes, but also the directions of those vectors. Vectors, remember, were things like velocity, displacement, acceleration, and force. All of those were examples of vectors. And since in this lesson we're going to be dealing with projectile motion, where things are going to be moving in 2 dimensions at the same time, we're going to be dealing with a lot of vector quantities. So we need to know how to mathematically treat those. That means we need to be able to add them, and we need to be able to subtract them. Occasionally you need to multiply vectors as well. Not so much in this lesson, but in some in the future. So when you have vectors, remember that vectors are first always represented with an arrow. The length of the arrow corresponds to the magnitude of the vector quantity, and the direction that is pointing on paper corresponds with the direction that the actual vector is pointing in the real world. Now, when mathematically dealing with vectors, there are 2 ways you can go about this. You could actually set up a scale and draw the vectors to scale and then actually literally measure the angles on paper, or you can also do that using trigonometry. And in this lesson we'll show you how to do it both ways. So first, if you want to add vectors together, when you're adding vectors, you've got to arrange them head to tail. In the lesson they give an example of somebody walking in a city. And they say, imagine walking first 9 blocks to the east and then turning and walking 5 blocks to the north. Well, we can represent those 2 segments of the walk with vectors, showing this 9 blocks to the east and 5 blocks to the north. Now, if you just add those numbers up, you've walked a total distance of 14 blocks. But when you're done, you are not 14 blocks away. In order to find out how far away, you just need to go directly from your starting point to your ending point. In the lesson, again, they talk about taking a helicopter. If you'd taken a helicopter for this instead of walking, you would have actually walked a distance of only 10.3 blocks directly to your destination. Well, that vector that is the direct answer, the 10.3 blocks, that's called a resultant. When you add vectors together, your answer is called a resultant, just like when you add numbers algebraically, your answer is called a sum. Here the answer is the resultant. And in this case, the resultant of this 9 and 5 block vector is a resultant of 10.3 blocks. But remember that vectors not only have a magnitude, they also have a direction. So we need to be able to describe exactly what direction this is. Now, before we do that, I want to point out one other thing. When I added these 2 vectors, the 9 and the 5, to come up with that resultant of 10.3 blocks, notice I could have done it the other way. That person could have walked the 5 blocks north first and then walked the 9 blocks to the east. It turns out your resultant is exactly the same either way. Same direction, same magnitude. When adding vectors, it makes no difference at all what order you add them in, as long as you arrange them head to tail and then make your resultant go from the tail of the first to the head of the last. Now, let's talk about how to describe that direction. Let's get rid of this for a minute and deal with just that resultant vector. So here's the vector, and we want to describe to somebody what direction it's pointing. Well, if we overlay the ordinal directions on it, north, south, east, and west, we can see that this vector is pointed somewhere off to the northeast. But if we just say, well, you've got to go 10.3 blocks northeast, that's not really precise enough. We need to know exactly what angle you need to head. What angle is this resultant actually pointed? Well, to do that, we need to compare the angle to either north or east, one of the standard directions. So suppose that we were pointing due east, like this, and we wanted to rotate and point in the direction that our resultant vector is. Well, how far would we need to rotate? Well, that angle's 29.1 degrees. So if we want to describe the direction that resultant is pointing, we can say, well, it's pointed 29.1 degrees north of east. But you might also notice, well, you could have measured this from north. That's valid as well. We could start at north and then rotate toward the east. And after we rotated 60.9 degrees toward the east, we would be pointed in the direction of the resultant as well. So that resultant could be described as either 10.3 blocks at 29 degrees north of east, or 10.3 blocks at 60.9 degrees east of north. Those are both describing the same resultant vector.